Okay, so I am going to be recording this part of the session. Again, if anybody has any objections with me recording this part of the session, please say so now. 5, 4, 3, 2, 1, boom. Thank you very much. So now we're going to be talking about absolute value inequalities. Okay? Now, for an absolute value inequality, now we're going to be working with absolute values, but we're going to be using the inequality symbols to relate the mathematical expressions. And so we are basically going to have two situations here. I'm sorry. One where the absolute value is less than a quantity right now, or another expression right now here expressed with A. And when we have this situation where we have absolute value less than another value, basically the expression can be rewritten as such. The inequality can be written as minus the value less than x less than the value. Okay? So let's say that I have an expression where I've got absolute value of x is less than a certain value, 2, for example. That means that the solution set is going to be between the negative value and the positive one. So if it's absolute value less than 2, we're really going to have a rewritten, or we can have a rewritten expression where we have minus 2 is less than x less than the absolute value. I'm sorry, the 2. In the case where I have an absolute value that has a greater than symbol, so absolute value of x is greater than a, so now the expression can be rewritten as such. And basically the rewritten expression is that x is going to be larger than a, or x can be less than minus a. So that means if I have the absolute value of x larger than 2, that means that the solution set x can be larger than 2 or less than minus 2. Okay? And both of these principles also apply to symbols of less than or equal or greater than or equal. Both of these apply. So let's find the equivalent inequality expressions for these two situations. For x larger than, x less than 1 and the absolute value of x larger than or equal than 5. Okay? So let's look at the first one. If I have the absolute value of x is less than 1, the less than means that the interval or the solution set has to be between the values of, in this case, the negative quantity, which would be minus 1, and the positive quantity, which would be 1. So the equivalent expression would be this one here. Let me just erase that. The equivalent expression would be the one that we see here, which is minus 1 less than x less than 1. Okay, this one would be the equivalent expression. Okay, now let's assume that we have another expression. Absolute value of x is larger than or equal than 5. So how do we represent this inequality as equivalent inequalities? We're going to have two situations. We're going to have x is larger than or equal than 5, and x is less than or equal than minus 5. So we're going to take the positive value, and it's going to be larger than, and the negative value, and it's going to be less than. And so this would be an equivalent expression in that case. Okay, so the way we're going to be working absolute value inequalities is we're going to be given an inequality that has an absolute value with less than or equal, greater than or equal. And when we have those, we're going to rewrite the expression as equivalent expressions depending on if we are given this situation or this situation. And the equivalent expressions are going to be written according to what we have here. Okay. Questions with this before we go on? Okay, thank you. So we're going to move along to the next examples. Now let's talk about some absolute value inequalities. And I'm going to give you a few minutes to work, to start working on these. If you've already solved the first one or any of these, then give me a thumbs up reaction, okay, when you've done so. So I'm going to give you guys a few minutes to do that. And I'm going to pause the recording while we do that. Recording. Okay, perfect. So now I'm going to resume recording. And so Andrea, you're going to show us your solution to the first problem. So just kind of walk us through it. And then I'm going to make some comments, observations, and I'm going to show my solution. So go ahead, Andrea, please.
Well, first I solve it like the normal way. So I just solve it like a simple one. And then I multiply this by a negative sign. So it gives me minus 3x plus 7 and is less than 1. And then I solve it and it gives me x is less than 2. So here are my two answers.
Sorry, perfect. Just leave it on the screen for a moment, please. So perfect. Let me just see. I'm trying to, I can't do any annotations, I think here, it's not letting me, okay. So this is a correct solution. So basically what Andrea did here, and your solution is correct, I'm just gonna add a few things to the explanation. So basically you've got we need to analyze this in two scenarios. The first is the positive scenario. So for the positive scenario, basically the only thing we do is remove the bars and we solve what we have on the left as a normal inequality. Okay, that's correct, right? Now the other scenario is the negative scenario. Okay, so in the negative scenario, what we need to do is that we need to multiply first by -1. And another thing that we have to notice is that we also have to do we have to refer a symbol change there, and we have to notice that, or else we're also going to be in trouble. And so the other thing here is that Andrea is multiplying by -1, and then she's doing the solving of the solution. Okay. Now thank you very much, Andrea. Now I'm going to share my screen. Thank you very much. And we're going to do this one before we go to break. And so let me go through the first one, and so we can look at the example. So you should be seeing the. I'm sorry, you should be seeing the screen. Give me a moment. There we go. Okay. So again, let's remember that when we're doing the inequality, okay, we have to, depending on if it's less than or greater than, we need to separate the inequality into an equivalent inequality. So we need to see which situation we're in, okay? So notice one thing here in the case of the first one, it's less than. So the way Andrea did it is that she separated it into two for the positive and the negative situation, but we just have to be careful with the symbols. Okay, so what we're actually doing here is that we're taking the inequality, okay, and since it's less than, the inequality is going to be here in the middle, and the inequality is going to be less than -1 and less than 1. Okay, so another way of separating this inequality into two parts, which is basically what Andrea did, but we need to be careful with the signs, and this is something that you need to verify, Andrea, is that there's actually two inequalities that we're doing here, and I'm going to mark them. One of them is this one, and the other one is this one, okay? So the positive inequality situation is the first one you had there, Andrea, right? 3x minus 7 is less than 1, okay? And when you solved this one, you got that x is less than 8 divided by 3, right? Are we okay up to this point? Okay. Now let's look at the other one. Just verify if the other one is correct. And remember that there's two ways of doing it. So for the other one, and I'm going to do that one over here, what we have, yes.
We can use like both methods, right? Like
Yes.
separate the equation or.
Yes, yes, we can do both of them, but we need to verify that we're putting, when we do either one, the one thing that we have to be very careful with is how to identify the signs that we're doing, okay? Just how to identify, I'm sorry, the symbols, okay? That's important. So Jose has a question. Let me just finish writing this down, Jose, and then I'll go over with you. So yes, you can do it on both ways, but we need to verify the symbols, that we're putting the symbols correctly. So the other inequality that we're representing here is 3x minus 7 is larger than minus 1. Or an equivalent way of doing exactly the same thing is saying that the negative, notice that what I'm going to write down here is exactly the same thing. I'm going to put this over here. The negative 3x minus 7, it would be less than 1, okay? And so once we do any of these, okay, we can do the solution to the problem. So if we solve it here, I'm just gonna erase this so we don't generate any confusion. If we solve this one here, we are going to get that x is going to be large. If we solve this one, okay, we are going to get that x is going to be larger than 2, okay? And so if we join these two, x larger than 2 and x less than 8/3, we get this solution that we have here, which would be the complete solution, okay? So the only thing that we need to verify is that we need to verify that we're placing the symbols correctly, okay? Now, before we go to break, and I'm going to give you the 10 minutes, don't worry. I think Jose had a question, and I think also Andrea. So Jose, go ahead. I think you raised your hand. No, Jose? Jose Guerrero, you raised your hand. Do you have a question? You still have your hand raised, Jose. Okay, if not, then Andrea.
I sent it in WhatsApp. I think I did it incorrect. I didn't change
The symbol, yeah. So the separation is correct, but when you multiply by the minus, you have to be careful about the when we're multiplying by the minus. That's basically why we flip the sign. So you got the values correct, and you separated it correctly, but you need to be mindful of the symbol. Okay.
Okay.
So just be careful with that. So the separation is correct. You multiplied by minus, but the symbol also flips. Okay. So remember that when we're working with inequalities that are when we're working with inequalities, the sign and the flipping of the symbols, those are the places where we can make a mistake. Okay, so be careful with that. Okay, good. So I'm going to stop pause recording, and then we are going to take a 10-minute break. Okay, good. So now we go to example 5b, and it says solve the absolute value of 2x minus 5 is less than or equal than 0. So we're going to apply the Gesell theorem of example 3b, and notice that an absolute value the result of an absolute value can never be negative. Okay, it can never be negative. So, however, notice please that it says that it's less than or equal. It doesn't just say less than, it's less than or equal. Okay, and so there is a value that complies with the solution, and it's the value that makes the inequality 0. That should be included because it says that less than or equal than 0. So what value makes 2x minus 5 0? That would be x equals 5 divided by 2. And so the solution set is just this value. It's only x equals 5 divided by 2, and that's because the expression is less than or equal. If the expression would have been less than, just less than, then there would have been no solution because there's no value that complies with the solutions, with the expression that we are given. Okay. Remember, if you have any questions, please either raise your hands or open your mics, and we'll stop for them. Okay. Okay, let's go to the next one. And so now we've got 4 minus 1/2 of x. The absolute value of that is larger than or equal than 7. Okay, and so we separate this. This is larger than or equal. So we're going to have the two opposite sides of the value, in this case, the minus 7. And so we're going to have, or we're going to separate the inequality into two inequalities. The first one is the positive one, okay? And the positive one is exactly the same as the original. We're just removing the absolutes. And the other inequality, and here going back to what we were talking about and what we noticed in Andrea's solution and that I was just mentioning to Estrella, is the other one is going to be exactly the same solution, okay? But we are going to be adding the negative, and we can add the negative on either side, but remember that we're also flipping the sign, the symbol. Okay, so the first one would be the positive, the scenario where the inequality or the absolute value is positive, and the other case that we have here is where the inequality is negative. Okay, and so for both of these, we solve them. These are linear inequalities. We get x is less than or equal than minus 6, and x is larger than or equal than 22. Okay. If we want to represent this in the number line, we can just do a quick representation here. In the number line, we've got minus 6 here. And then let's say we've got 22 here. And so the solution is going to be represented by those values. And in the case of both of these values, we're talking about a less than or equal and a greater than or equal. So these are going to be bracketed. So one solution is going to be less than 6. The other solution is going to be larger than 22. So what we're going to have here is values that are less than 6, including 6, values that are larger than 22, including 22. And the solution, if we're going to represent it as an interval, we're going to have minus infinite, 2 minus 6, and this would be bracketed, an open interval here, union with 22 to infinite. Okay. So that would be the solution represented as an interval and also in the number one. Okay. And again, what we have to be very careful with, whenever we're working with absolute values, there's going to be two scenarios that we can do them either separately in the case of the less than or combined. And in the case of the larger than, we're always going to have to separate these. And the first one is going to be the positive scenario, which is going to be exactly the same inequality, but removing the absolute value bars. And the other is going to be the negative version, which is going to be multiplied by minus. And since we're multiplying by minus, we have to flip the symbol. Okay. Questions with this one before we go on?
Yes, I have a question.
Yes, go ahead, Javier.
Kind of got confused with that the signs flip when you multiply by a negative number. And my question is, why they don't flip in this case?
Okay, could you repeat the last part again, please?
That when we multiply by a negative number, in inequalities, the signs like flip. But in this case, they don't. So that was why.
No, actually, if you notice, Javier, they do. Look, notice that there's going to be two scenarios. So the first one is the one on the left. The first one is the normal inequality. It's the positive version, right? That's the one on the left. So it's exactly the same one, but I'm removing the bars, okay? Now let's go to, there's no multiplication by a negative and there's no symbol flip, okay? You notice that this one is exactly the same as this one, right? Okay, now let's go to the other one, okay? Now let's go to the one on the right. In the one on the right is the negative scenario. And for the negative scenario, notice that we are multiplying by minus. Notice that instead of 7, it's minus 7, okay? And notice also that we had a larger than or equal, and now it's less than or equal. So we're multiplying by the minus, and the symbol is flipping.
Okay, yeah. I wrote it down wrong. Sorry.
I'm sorry, you what? I didn't hear those.
I wrote it down wrong.
Oh,
like,
okay.
My first step.
So your observation your observation was correct. You do have to flip. You multiply by a negative and the symbol flips. That's always going to happen. Okay, thank you, Javier. Any additional questions? Okay, let's go on to the next one. Now, in the next one, some of the in the homework task, there's some problems here where we're working with the inequality the other way around. We're given an expression, and given the expression and the characteristics of an inequality, we want to find and given the solution set, we want to find the values of the inequality. So, right now, for example 7, it says find an inequality of form x minus b less than a, for which the open interval 4, 8 is the solution set, okay? So we're given an inequality, we don't know the values of b and a, we need to find the values of b and a, and represent this solution set as an absolute value inequality. So how do we do that? Well, first off, we need to notice that this inequality here is less than inequality, so the equivalent expression, let me correct this. The equivalent expression is this one here. The equivalent expression would be this one. And by the way, again, like we were mentioning, there's two ways to do this. We can represent it like this, or we could also say that we have two expressions, which is x minus b less than a. And we can also say that x minus b is larger than minus A. Either of those expressions is we can represent it like this or with these two. Okay, either way would be correct, and we can solve based on either of these. Okay, and so if we do that, we find an expression. If we send this b to the other side, we have minus a plus b is less than x less than a plus b. We could also do this here. We could say that x, I'm going to do it on both ways. X is less than a plus b. And over here, we're going to have that x is larger than b minus a. Okay. Now, the interval that we're given is 4 and 8. Okay. So if we've got x is less than a plus b and x is larger than b minus a, then this means that the intervals have to be congruent with what we have here. Okay. So that's what we have over here. In this case, x less than a plus b has to be the larger number. So in this case, a plus b would have to be equal to the larger number because it's less than that. And b minus a would have to be equal to the lesser number, which in this case is 4. We have two equations that are two simultaneous equations. Solving these two equations by any means that we can, we get the two values of a and b, which are b is equal to 6 and a is equal to 2. Those would be the two values that comply with the solution of the problem. Okay, and so if we substitute these in the original expression, we're going to have x minus 6 is less than 2. Okay? How do we solve these simultaneous equations? We can solve for a and substitute in the other, or we can simply add them, and we're going to get this. We would get these two results. Okay. This is an example where we're given a solution set and an expression, and we need to relate them. Okay? How do we relate them? Using the properties of the absolute value that we already saw previously. Okay. Now, questions with this example before we move on. Okay. Now, we're going to do the following. This is going to be a bonus exercise. So we've got this inequality, and we're going to see how to solve it here in class. But we've got this inequality right here. Okay. I want you guys to work on this inequality, and the first house that sends me at any point during the day, you have today to do this. The first house that sends me the correct solution to the whole WhatsApp group, not personally, you have to send it to the whole WhatsApp group, a screenshot that's readable. The first house that sends it to me and is correct is going to get 4 points. It's just the first house that does it correctly. Okay. So it can be any team, any member of the house that sends it. If it's correct, the first one that's correct is going to get 4 points awarded. That's at any point today, and we're going to solve it in class later. We're going to solve it in class later. Okay, is it clear? So the solution to this one, and we're going to solve it in class, but whoever does that is going to get some points. Okay. Questions up to this point? Okay. Now, I'm going to do the stopping of the share for a moment and stopping the recording.